So we're live. Hello, hello. Guten Abend. Good evening. What was I even doing? Clojure. More Clojure problems. Okay, let's do that. Let's get into it. Let's get back to it. Oops. Oh, what is that? Nrepl port. Interesting. I don't know what that is, but okay. Alright, so re-implement iterate. Okay. Given a side effect free function f and an initial value x, write a function which returns an infinite lazy sequence of x, f of x, f of x, f of x, etc. Okay, so I think I know what to do. Actually, this is not as bad as we might think. As you might think, this is likely. So we'll say iterate 2, and we're going to take a function. We're going to use pre to check that f is a function, right? Precondition. And what we're going to do is take initial value, initial, or just val, or v. Should be val, should be v. And we shouldn't do this in here either. We should do this in the other editor. That's better. And what we want to do is, so you're going to iterate. So you're going to apply f repeatedly. Now, the way this is going to work is it's going to be a recursive function. So it's going to be a lazy sequence that you want. And you're going to, at the bottom of this, you're going to iterate. But you're going to cons v with iterate 2. And you're going to provide f to iterate 2. And you're going to provide f applied to v. And I think that ought to do it. Let me see if we have like just addition. So if we take this and just define it here, right? Whoa. Interesting. Okay. And then now I want to execute iterate 2 over, I guess we'll just do addition, and with the initial value of 0. And we can do an anonymous function that just takes, takes a value and adds, let's say, 3 to it, right? And if we take 5, right? Now this could crash the REPL. Oh, it works. Works exactly as expected. Holy smokes. No kidding. Wow. Really? Amazing. Amazing. No kidding. Getting the hang of this. I'm getting the hang of this, man. Heck yeah. Heck yeah. Wow. Not bad. Not bad. Yeah, I could have put this on the same line. Yeah, okay. It's an easy problem. Alright, fair enough. I don't have to spend too much time on that. Group a sequence. So given a function f and a sequence s, write a function which returns a map. The keys should be the values of f applied to each item in s. The value at each key should be a vector of corresponding items in the order they appear in s. Given a function f and a sequence s, write a function which returns a map. The keys should be the values of f applied to each item in s. The value at each key should be a vector of corresponding items in the order they appear in s. Oh, I gotta read that a few times. So, given a function, oh, yeah. Oh, this is interesting. Yeah, okay. And there's gonna be a vector. Oh, this is so cool. Yeah, all right. I know what to do. Yeah, this is pretty neat. Watch this. So, let's group by. Right, I think I understand. All right, so how can we do this? Yeah, we could just, this is like a frequency map, but just a little bit different. So what we're going to do, I could one-liner this, I think. What we're going to do is use a reduce, and it'll be a hash map, and we're going to, yeah, okay, so simple reduce should do it. So here, we'll just try a test case. Or use a test case. I think I know what to do here. So we use, what do we say here? This was, or is, group by 2, we'll say. And group by 2, and we'll say, take a predicate and a collection, predicate, collection. All right, and this predicate, same thing, could do a pre, is a function, predicate, and we'll say, we're going to reduce, simple reduction. We can actually make this anonymous. No, I prefer not to make it anonymous because we want this check, I think. And so we're going to do perform a reduce, and the reduce is, we're going to have a hash map at the end of this. And we're going to loop through each value in the collection, and the magic is going to happen within this anonymous function. We're going to associate with, so we've got, yes, okay. It's two arguments, right? V and the thing that's going to return. I kind of like naming the function. It's just a little easier, I think, for me to operate like this. Yeah, because I can call it retv, and so this is the final result, and this is the value at each iteration. It's like easier to wrap my brain around rather than like %1, %2. It's like a little less like when you're articulating the thoughts, it's like a little less comfortable. So you want to associate with ret and return it. The key is going to be f, or predicate, applied to, or keygen, we'll call it. So yeah, call it keygen, or yeah, keygen, I think is what we want. So call this function, and you're going to say keygen of v, you're going to get from ret. So ret of keygen of v, and this should give you, if to the default, there'll be a new vector if it doesn't exist already. And no, excuse me. Keygen of v is the key. Yes. So that's the key that you're going to associate with, and the value is going to be this, also associated with, conjoined with v. Yeah. So there you go. So that's your function that you're going to use reduce on. And that should do it. Pretty simple. So let's do this. Define this function, group by 2. Copy that, throw that in there, and then try to keygen 2 of, oh no, group by 2 of these values. I think in line run might actually be faster than doing it this way. False true. 1, 3, 6, 8. Perfect. That's what we want. Because I have to copy the changes here and then I'm actually not sure if it's faster now. Put all that time into changing the REPL here, and it's like, wait, this might not actually be much faster. Oh, no. Copy. That's what we want. Nice. Nice. Okay. Not too bad. Not too bad. Okay. So, okay. Update in is another thing I could have used instead of associate. I kind of prefer associate. Update in kind of confuses me sometimes. It does almost the same thing. If we look at what update in does, it's very similar. It's almost, I don't want to say there's no difference, but it's really similar. Nested associative structure, sequence of keys. Okay, this could be a sequence of keys, whereas associate is not necessarily a sequence of keys. So maybe you do want update in if you return a sequence of keys with this keygen. I wonder. Yeah. That's interesting. Sequence update in might be better because it can get pretty complicated. This group by maybe. I don't know. I don't know. I don't know about that. I don't know. Nah, I think even it's simple with associates probably the way to do it. Using a sequence of keys, I guess, is like can get just a little confusing. Yeah. I don't know. I don't know what to think of that. I don't know. I'm not gonna think about it more though. Move on. I think, generally speaking, it would probably be kind of confusing to use update in too much. Using it a lot. Maybe this was better. So yeah, pretty simple. Okay. All right. Move on. Move on. I don't think I need to really look at this too much. All right. Intro to reduce. Did I set my alarm? 7 p.m. I said. Yeah. Okay. That's fine. Is my phone charging? Thing has been kind of pain in the neck lately because the charger is kind of weak. Like it doesn't have like a. Yeah, there we go. Okay, it hasn't really been charging properly lately. Annoying. Okay. Intro to reduce. Reduce takes a 2-argument function and an optional starting value. It then applies the function to the first 2 items in the sequence, the starting value, and the first element of the sequence. In the next iteration, the function will be called on the previous return value and the next item from the sequence, thus reducing the entire collection to 1 value. Don't worry, it's not as complicated as it sounds. Yeah, we implemented this previously. We used reductions though rather than reduce. So it looks like we're going to implement reduce. Oh no, excuse me. We're not going to implement reduce. We're going to use reduce. So this one we probably want. We can do actually just the sum. I think will work. Oh, wait a minute. Is that 15? If you add these together, 9, 12. Yeah, I think it's 15. If you add this together, it's 0. If you add, yeah, it should be 6. Starting at 1. Yeah. Okay. Okay, got it. Black box testing. Clojure has, whoa! Whoa! Talk about restrictions, okay. Clojure has many sequence types which act in subtly different ways. The core functions typically convert them into a uniform quote-unquote sequence type and work with them that way, but it can be important to understand the behavioral and performance differences so that you can know which kind is appropriate for your application. Write a function which takes a collection and returns one of map, set, list, or vector describing the type of collection it was given. You won't be allowed to inspect their class or use the built-in predicates like list, ? The point is to poke at them and understand their behavior. Oh, I can't use type. No! What do you mean? Oh, it's horrible. I wouldn't do that. No, don't do that. What? What do you mean poke at it? What? Excuse me? What are we doing here? I don't want to do this. This is not the way to, another way to figure. Okay. All right. Oh. Excuse me? Excuse me? Unbelievable. Unbelievable. Alright. Write a function which takes a collection and returns one of map, set, list, or vector. Alright. There's only 4 different possibilities I care about here. Describing the type of collection it was given. So implement type is basically what we're, or class is what we're looking for here. You won't be allowed to inspect their class or use the built-in predicates like list. Point is to poke at them and understand behavior. Can I not? Even though, wait a minute. So a map, if we look at Clojure map, right? It implements a Java, hold on. No. Excuse me, these are just keywords. If it's a map or array map. So let's do a hash map. Alright, let's go Java hash map. Okay. This, in the Clojure core, underneath how it's programmed, hash map. Okay. Hash map, okay. If we go to the GitHub, yeah, there we go. Clojure lang persistent array map. So this is actually what I want to see. Is if we go to the GitHub and look at the persistent array map and the persistent map. Let me see here. Okay. Array map. Alright, if we look at this bad boy. Take a look at this here. Take a look at this here. And what have we got? Okay. So this is implemented in Java, right? Now, the suggestion was that we cannot look at the class. Can't inspect the class. I want to say we can use what I want to do is use the Java interop to print the interfaces that it implements. I guess that would be inspecting the class, though. You know, I guess it would be. I guess I'd be cheating. I don't know. I feel like that's the way I would do this. If I genuinely wanted to code this, I would probably. What am I doing here? What are we doing? Is that kosher? Can I do that? Let's start with that question. Is it okay to? No, that would be inspecting the class, wouldn't it? If I just asked which which interfaces does this implement, or what does this extend? Yeah, that's knowing the class that it implements. Yeah, okay, that's fair. There's probably a Java interop function I can use. I guess that's the get class is what they were saying, is that you can't just use get class. That's probably from the interop. Okay, fine. Because then it's very easy, right? What the suggestion is then is the idea is then behavioral and performance differences so that you know which kind is appropriate for your application. Write a function which takes a collection and returns one of map, set, list, or vector, describing the type of collection it was given. You won't be allowed to inspect their class or use the built-in predicates like list. The point is to poke at them and understand their behavior. Alright, fair enough. How do we solve this then? How do we do this? Type of collection it was given. Describing the type of collection it was given. Won't be allowed to inspect the class or use the built-in predicates. Poke at them and understand their behavior. So something that a map does that's unique with regard to the other three possibilities. Maybe I should focus on this case. This seems like the best case to look at. Interesting, very interesting question. But yeah, if I were to solve this in the wild, so to speak, I mean it's a built-in, so you wouldn't really need to. But if I had to, right, thinking about compiler, building compilers and adding to a language and things of that nature, right? Some these are probably things that you would want to have if you're going to write your own functional language. I don't know if I anticipate myself ever writing my own language, but one consideration is to write in C++, write like a functional library that basically has all the Clojure functions. In theory, you can do that, so that way you have the speed of C++, but now it's in a functional language, and so you don't need to use things like OCaml. And so you can write systems level programming in a functional programming language. Like, that's an idea. It's a thing that could be done. Do I intend to do that? No. But, going through these exercises would make that a possibility. And you'd probably get a lot of credit for doing that because you end up with some incredibly efficient code and maintainable code. And so you have sort of vastly improved systems level programming, I guess. I don't know. And you can also do concurrency better and things of that nature, which is probably pretty good for like machine learning algorithms. Which, like I said, is one of the reasons I want to learn this, is for that reason. I have an interest in machine learning, but I'm like really far off from actually doing anything involving machine learning, at least for a while. All right. So, okay. So we have this function, we want to map it to, yeah, okay, that's fine. But what are some properties of each of these things that are unique from one compared to the other three? For each one, there's maybe some property or properties regarding that particular object that would be unique with respect to the others. So a sequence, What's unique with respect to a sequence? It's different from the it's different from like a vector. So something that's unique to a sequence, but you can't do it. You can do it with a sequence, but you can't do it with a vector. Or yeah, some behavior. When you, let's see, if you add an item to the sequence, you can't cons to to any of these, I think. So if you just type like cons 1 with just a sequence. Also, I don't think that worth. This needs to be quoted. Not sure if that'll give you a sequence. It does. Okay, interesting. Yeah, so if you cons 1 with something, a vector, it works. Cons 1 with a map, or no, a set. Cons 1 with a hash map. Huh. You get a sequence, no matter what you do. These collections. All right, so adding values isn't really gonna tell us too much, I guess. What if you do cons 1, cons 1, cons 2, right? Add two things. Okay, 1, 2. How about the regular sequence? You get the same thing. All of these seem to be returning just a sequence. Well, it doesn't seem to be much different from one to the other. One to the other. They all just need to print a sequence here. What if we print the thing? One, two, nil. What is that? Whoa. Okay. Also nil. 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 Huh? That's utterly confusing. I am flummoxed. I don't know. I don't know what I'm looking at here. Can I print things? Oh. Oh, wow. Okay. Oh, this is wild. I see what's happening. So, watch this. How do I show this? What this is doing? It's printing a Oh wow, that's very interesting. So it's executing the command, and then it's printing the result of the command. So when you print, the result is nil. So it prints nil, but it also executes print. So it prints REPL, and then prints nil. Oh, that's very interesting. The thing that's weird though is it doesn't print like 1, 2. Oh, it does. Okay. So yeah, the print will actually show you the correct characters. I guess it's a vector or sequence, but it looks like if you just create the thing, it's just doesn't matter which one of these you use. It'll show you like a sequence. I guess it interprets the sequence differently. Like if you do cons 1, cons 2 of this guy, or the map, and then you print that, that's going to be kind of special. Oh no. Maybe those are just keys. Hmm. Interesting. Oh. I think cons always gives you a sequence. Oh. Okay. Okay, I see. So you always get a sequence here. Hmm. Hmm. Stolen from a YouTuber. Is that really? It's kind of trivial. Um. Hmm. Who did that? 2014. I think I did that too. I'm looking at it like, wait a minute, I did this. I did this a few days ago. Because it's a trivial thing. It's like, what? Okay, anyway. Hmm. Create lazy sequences. So it always returns a sequence, so we actually don't want to use cons, but maybe conjoin does something interesting. If you conjoin values. I really don't know how to solve this one. I mean, I don't know what to think, what to do. Conj. Other way around, okay. Aha! Aha. So conjoin doesn't work for a map or a set. Oh no, it works for a set. So it just doesn't work for a map. So we can at least eliminate whether or not it's a map. We can use conjoin on a map. We'll get an exception. So that's one down. You just process elimination, right, to get the other ones. So conjoin on a map will throw an error. So we can at least use that. Okay, perfect. What are the other properties, the other two? Set, vector, and list. So the thing that's interesting is you can join on a vector a few times, right? Do that a few times. Do that like 3 times, say. And you do this, right? So each time we'll say conj 1, and we'll say get, let's say last, just say last, right? Print last. Well, okay, just do the show last, right? That's 1. If we do conj again, get 2. Finally, we should get 3. Okay. If we perform the same operation on a sequence, though, 1 is the last. So what we can do is we can check if this is a question between, if we've eliminated a map, and now we've got a question between a list and a vector. Oh, but it's a list? Wait a minute. Oh, what the heck is it? A list is not the same thing as a sequence. Ah, come on, man. No. Okay, let's see. Uh-oh. So I guess a list is a sequence. Same thing. Maybe we can look at the, now maybe this is a case where we do want to look at the core and see, take a look at the language. Let's see. Sequence. List. Index sequence. Persistent list. Yeah, okay. Let's look at each of these. Whew. A sequence. List serializable hash EQ. Hash EQ. String to string. Collection empty. A sequence. Persistent map meta. What am I looking for here? I don't know if sequence is the same thing as a list. Oh, it's an interface. Oh, sequential. Persistent stack. Implement sequential. persistent stack. Can I create a list of things? Oh, okay, there we go. Yeah, persistent list extends a sequence. All right, great. So sequence, persistent list is a sequence, I think. It's an extension of a sequence. All right. Primordial. Primordial ooze. That's the what's suggested about life, right? Primordial ooze. Way back when, there was some primordial ooze that generated the first life on Earth. That's the suggestion. And actually, it's even glorified in Magic the Gathering. Primordial ocean ooze or soup. Primordial sea. Stable enough to still occur on Earth before the Earth came into existence. The elements before the Earth came into existence. That's the primordial ooze. Existing at or the beginning of time. Primeval. Primordial. Primordial. That's fun. Now this is kind of interesting. It looks like this is an inner class to the persistent list. It's a primordial class. It's pretty funny. See this? Opening brace contains this. Looks like it contains a few sort of inner classes, I guess. Although what's interesting is that they're public inner classes and they're static as well. So it's kind of unusual. I don't know how unusual that is, but it's how it's been done. Excuse me. So all right. So you got this persistent list. It extends a sequence. So it's a sequence plus a little more. So all right, fine. All right. Let's see. Can we create a list and conjoin to it? Maybe. Okay. Oh, it works. Yeah. All right. I thought. Oh. All right. Yeah. All right. Makes sense. It's variadic. Yeah. Okay. What am I complaining? What am I worried about? What am I worried about? So we can do the same thing here and show, right? It'll still be a 1. Okay. So that gives us a way to differentiate between. So we can outright we can try to cons to a map and see if we get an exception, right? If we get an exception, then we know it is or isn't a map, right? That's unique to the map. These others will cons. Map's the only one that won't cons. So great. So we eliminate map. If we're trying to choose between a vector or a list, then we can use the property I just described. Just add 2 elements and check the last. If the first element you added is the last, then you've got one of these 2, and then the other case is this mirrored case. I forget which one is which. I think you do the last seems to be the second. The first element will be the last of the list, and the second element will be the last of the vector, right? If we do this using a vector. Whoa. Vector, on the other hand, you can't create with a single. You need at least one argument. You need actually a collection vector, I think. So yeah, so vector would be the other way around. Great. So we have a way to. So we can eliminate. So now we just got to eliminate a set. So what's a unique property to a set that we can use to narrow it down? Something unique to a set. Well, adding elements. Well, the problem with this set is it's sorted. That's the difference. You can cons anything to it. You can, if you add things, multiple things to it, it doesn't really change much because it's sorted, so it doesn't really. Oh, I think I know what to do. If you conjoin with the set the same element twice, an element that's not in the set, you gotta find an element that's not in the set though. Oh, I have an idea. Yeah. Okay, I got it. If you add an element to the set, if it's in the set already, it won't increase the size of the set. If it's not in the set, now it is, you can add it again and it won't increase the size. That's how you can tell if it's a set or not. So that's unique to a set. All the other cases, you can always add more, it'll increase the size. So if you conj to twice, let's say, and take the size, right, that's size 2, and then we'll even conj one more time. Size 3. If you do that with a sequence, right, it'll increase by 2, or it'll increase. But if you do that with a set, how do I create a set? Oh, I know. Yeah, it doesn't work. You have to use these special characters. Ah, you see that? Only size 2. Aha. So if you add an element like 1, and if it increases the set size, if it doesn't increase the set size, then you're looking at a set. If it does, you can add it again, and then if it doesn't increase the second time, then you know it's a set. Otherwise, it's not a set. Yeah, there you go. Kind of involved, those two, but there you go. There's you do the first 2 checks. One check checks if it's a map, whether or not you can cons to it. If it's a map, then you return map. If it's not, continue. The next check is check if it's a set by adding 1 twice and checking each time if it increases. If it doesn't increase in either of those cases, then it is a set. Any other case, it's not a set, and then you can check adding 1 and then adding 2 and checking which one is first or which one is last, and that'll tell you if it's a vector or a list. Yeah, there you go. That's it. Pretty interesting. Pretty interesting. So let's do that. Okay, define function. Alrighty. Type, or we'll call it collection type, because this is kind of special. This is not the way I would normally do it. I think. Give it a collection. You want to say, okay, first we'll do a map. So we want to try catch, right? Try catch. So we're going to learn about try catch now, and we want to say if it's a map, we want a cons. So the try is going to be cons 1 to the collection, right? Cons 1 to the collection of map. And what error did I get also? Clojure try and catch. So if we cons 1, oh, no, it's conjoin 1. It's conj. There we go. Class cast exception. All right. So conjoin 1 to the collection. Try catch. Let's read what the troll. Not what I wanted. No exceptions occur, the last value is returned. If an exception occurs and catch clauses are provided, each is examined in turn, and the first for which the thrown exception is an instance of the name class is considered a matching catch clause. So I don't know also how do you break out of the try. So it's try catch. Okay, caught exception divided by 0. Expressions are evaluated, and if no exceptions occur, the value of the last is returned. Okay. So interesting. So conj 1 collection. The catch exception E. We'll just say, does it matter exception type? SQL exception. SE exception 2. Generic exception. Final clause. How does the catch work? Oh, I'm so itchy. So itchy. What is the, like, how does the catch work exactly? Like, there's different exceptions, but I don't know. I guess you have to, what kind of exception is this? Class cast exception. Okay. All right, that's fine. Call it CCE. And what happens next? And within the catch, 111, what is that? E message string. Okay. Caught exception get message. E. All right. So this is a function, I guess, that takes this variable. That's kind of confusing. But anyway, what we're going to do is print, we're going to return, I guess, map would be what we do. So let's try this now. Okay, and then you're going to say collection type of map. Oh, it worked. Wow, amazing. Amazing. So if you don't get an exception, you're going to execute the rest of the body, which is, now let's test for whether it's a set. So what you can do is, no, I think we'll keep it here. I was gonna say, like, you could write some local functions to handle these pieces. Yeah, actually that's fine. Let's do that. That's better. Let's do that. So let's write a let, and let's put this inside. Okay. What we're gonna want to do is collection type, collection let. I want to say is set. I think we should actually do it this way. Is map should be this one. I like that better. So we can do, like, properly do a process by elimination kind of deal. And we'll say try catch. This will be so is map. We'll say true. And this will say false, right? So isMap will give you this function, just an anonymous function. I could take the collection. It doesn't really have to. I mean, okay. And sort of rename, yeah, it'll be a different name for the collection here. Okay. And then isSet, take the function, take the collection, decide what you want to do with it. We'll say it's a set when, we know it's a set when we say, okay, conjoin 1 to the collection, and you will say if this is equal to, if the size, if map count to conjoin 1 and conjoin 2. If we say, oh, this is kind of interesting. Can we do a reduce or just a map? What if we do this? We do map function. You're going to say you're going to count the result of applying conj of this value to this collection, right? And you're going to do that over 1, 2, sequence 1, 2, right? And if this is, and then you're going to say equals, if they're equal to each other or not. How do you express that? Size doesn't change after how do you check that? Reduce over equals, maybe, if they're all the same. How would you check that? All have the same value. It's actually not really like a trivial thing to check. Over the sequence. This returns a sequence now. Could do this. That works. That works. Okay. So if, we're gonna say if this or a similar thing, almost the same thing, we're gonna say, instead of conj percent collection, we're gonna say apply oh, it's the other way around, isn't it? Did this wrong, huh? Oh. No, conjoin. I did this wrong. I did this wrong. Let's supposed to go the other way around. Illegal argument exception. Call that an IAE. Okay. Anyway, so if you now what you do is you say apply a 1, no, apply a 2, and then apply a 2, 2. And you're going to go ahead and suggest, so if you, it should be the other way around. Now what you do is say if you apply each of these values, you can join. Now can you conjoin with multiple values? Conj 1, 1. You can. Yeah, there we go. Okay. So now if we push 2 values in, right, apply all these values. So one case we push a 2, the other case we push 2, 2. If 2 is already present, then this should be equal if it's a set. If 2 is not present, you'll still have the same amount. You'll have 1 element added each time. So if you add an element, oh, actually this is all we have to check. Yeah, oh, never mind. Why am I even doing this? This is no or. You don't need this or. It's literally just this check. Because if you apply, if this element is not present, you add it once, it increases, it has a certain, it's sort of whatever the size plus 1. If it wasn't present, you add it again, you add these 2, then it's still going to be size plus 1, right? If this is present, then it stays the same size in both cases. So present or not present, you're going to get the same size. If it's not a set though, then you won't get the same size, which is what you want. So pretty nifty little check here that we do. But that's actually it. No, that's it. We don't need anything else. Let's just return this value. If this is true or not. Pretty nifty little check here. And now we say, we'll say, if it's between a list or so list or vector, right, true being list, and then false being not list, meaning it's a vector. Then we'll take this collection and we'll say, okay, we want to know if it's a list, so let's determine if it's a list or a vector. Now that we know it's not a map, it's not a set, so it's either a list or a vector, what it means is you're going to take cons of collection, and now the cons goes the other way around. Cons of collection, you're going to put a 1 in there. Then you're going to say cons of this collection, put a 2 in there, right? So cons 1 of empty list, cons 2 of an empty list, and then we want the first or the last of this, right? Not cosine, but not cos, but cons. Okay. Last will give you a 1. All right. If we change this to a vector, last is still a 1. What? Excuse me? Okay, how about first? How about 1, 2, 3 of these? Still go last. Change this to right. Okay, it's not. Let's go first. Okay, this is not what I was expecting. What? What happened? Is it conjoined maybe is what we're missing? Maybe it should be conj, not cons. Apparently. Oh yeah, I'm sorry. Cons returns a vector, rather a sequence each time, so you're not going to get a difference. It's the other way around. It's conj is totally different. Totally different. Okay. There we go. That's what we want. And first, last, same difference. Do last. Should get a similar kind of a thing going on. There we go. Okay. 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 Okie dokie. So, right. So if we can join, we don't need to do three. We could just do 2 and 1. We don't need to do 3. That's too many. It's not necessary. So if we can join on a list, the last thing is actually not going to be 2. If we can join on a vector, the last should be 2. That's what we want to check. So vector or list, it really should be. Vector or list, and this is going to be conj of conj collection 1, collection 2, and last will be 2 equals 2. That means this means it's a vector. If it's not true, that means the list, right? True is vector, false is list. Done. Okay. So what do? We say a bunch of if-else statements here. If, now here's the question, do I need, this would probably just, yeah, like that. I prefer that. All right, there we go. Kind of involved, not a particularly hard problem, but you know, there's some stuff going on here. So is map of collection. If is map, then map. Else, another if statement. If, nice nested. If it's a set, turn set. Otherwise, if vector or list collection, then we say if it's a vector, return vector. If it's a list, return list. And that's it. That's our process by elimination here. Alrighty. Now, take this collection type, put it in there, load them up, and say, run this check. Map of collection type. Let's see how this goes. What do we get? No, we got map vector vector list. No. 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 You gotta be kidding me. What are you talking about? What? What in the Sam Hill? Oh, I think I know why. Because this has gotta be. Oh, no. Yeah. Wait. Uh-oh. Right. I made a mistake. Oh no. Wait. What? I think I made a mistake. Let's try that again. Yeah, this is kind of an issue. It's not actually that much more efficient. Then just running line run. Set. Map set. Okay. I see the problem here. This is whoops. Alright, let's try this. I still think this is faster, but it's a little less fast using line. Line run is not as using the REPL is faster, but it doesn't get much more speed once it's done and I run it. It's not really much faster, but it is definitely faster. Definitely faster than when I'm doing these sort of in-between operations. So if we map collection, right, and we just say, okay, how about the collection is this guy, like, or rather, yeah, this guy. What does that look like? 1-1. What? Wait, what? What happened there? What is going on? Hello? And that's a set. And then the other one is anything else, right? Like a vector. What is going on? Why? Oh, count. Oh, that's right. Yeah, that makes sense. That's the count. That's why. Yeah. Okay. So vector is not going to have the same size. Hash set won't make any sense. Yeah, vector doesn't. Vector works. Hash set doesn't make sense. Hash map doesn't make sense. Hash set works, and then a sequence. Also, we get 1, 2. Okay, yeah. But then what is? So then, if we do this, we get a problem. True. No, shouldn't be true. What about apply? Maybe that's the problem. Ah, there we go. Okay. Yeah, so we're right. We're fine. So this should be, yeah. All right, got it. Well, so let me get going here. Let me just finish this up quickly, and then we'll go. There we go. Ta-da! Map set vector list. Cool. Very cool. Shift tab. Take off that. Oh, kind of wanted to do that first, I think. Copy. Throw that in. Oh, no, not here. Throw that in this guy. Bada bing, bada boom. See how that goes. Fail immediately. Catch is bad. Oh, we can't use catch. No. What? What do you mean? Oh, what? Unbelievable. This is I can't believe this. Oh. You're kidding. No. Don't do that. Don't do this to me. Don't do this to me. Oh my goodness. No, we can't conjoin on the map for this one. No, these are exclusive. No, these are mutually exclusive things. Why would... No, say it ain't so. Say it ain't so. Can't use... Apparently catch, but we can use try, though. Right? Try, I could just do try and finally. Or no, yeah. Actually, I don't know. What happens if you do this? Does it still work? So I gotta get going. Promised the pops we would get together and do stuff. Okay. No. No. There's no catch, then it just throws an exception. There's no. Okay. What if you cons? No. Excuse me. No. 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 You can do no, you can't do these other ones because they'll throw exceptions. Oh, come on, man. What do you mean you can't use catch for this? We're supposed to be looking at the behavior. Ah, it's bullspit. 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 Alright, I gotta get going, but I think I'll come back to this. Let me think for like a minute more. Excuse me. Excuse me. Excuse me. Map set list vector, describe the type of collection was given. Won't be allowed to inspect their class or use the built-in predicates like list. The point is to poke at them. Yeah, but what do you even do with a map that determines whether or not it's a map? How does that work? I guess a unique key, maybe. So you could try to get from the map a particular key, and then, default to nil if it's not there. And if it is there, then you can associate. See, I don't think get works if you do anything that's not a map, right? Like if you just get from 1, 2, right? 2. Oh. Oh. Interesting. So you can get, and then what if you associate? Like what happens if you associate on this thing? Key must be integer. This will throw if you try to associate on the hash map. Right. You can't. No. It don't work like that. Yeah. Yeah, you won't. It doesn't work. Like if it just shucks. Maybe we can eliminate the other cases first. Try that. Vector or list. But the problem is that if you conjoin with a hash map, like it'll throw. So you can't do that. What can we do with any type that can tell us whether or not it's a hash map or not? Like, how do we do this? I don't know, man. Like, these are great, but these two, but they don't work for hash maps because it'll throw, and then you gotta catch. Otherwise, your program doesn't work. You need to catch. Is there any way we could do this without catching? Apparently you can, but alright, I'm gonna get going, I think. A minute or two. Let me think for a minute more. What are things you can do with a hash map that won't throw, that you can determine that it's a hash map? Like the get is pretty good. I'm wondering if you can con something twice and then get instead of associate. Maybe you can use just cons. I don't think that works though, because cons you can do with everything. But this gives you a sequence. It doesn't give you. No, it doesn't help at all. Maybe update in, something like that. Update in throw. I bet you it does. Yeah. Oh, function, right? I don't know. Just do function that returns the first variable. What is its key? I don't know. What does this do? I don't use updated enough to know. Map keys function args. Map keys function arguments. Users age increment. Function will take the old value and any supplied arguments return the new value. Oh, okay. So we have old value x, something like this. This doesn't work? Key must be an integer. Yeah, you get the same error. If it looks like this, then you're fine. Stretch my hands to you. This catch would be so good here. Oh, can't use it. I don't know. I don't know. I mean, ideally you'd say if these are false, but you can't use these because they're not these cons, because you can't use cons on a hash map. It'll crash. And you won't be able to tell if it's a vector or a list, because it could be a vector or a list or a map. Something like that. I'll stretch my hands to you. Assuming it's not a map or a set. And this is clear. I should know that. Oh, I don't know, man. Maybe we don't need to determine if it's a map. Maybe we want to determine if it's these three using something that we can also apply to a map. How does that even work? How does that even work? We can do cons. I mean, we can treat the map like a collection. You know what we can do? I have an idea. Okay, I have a better idea. I got it. I think I got it. I know what to do. We're gonna dump the map into a, well, even that's not clear because it could be a sequence of, like, you could have a vector or a list of just, it's not, no, man. Okay, I got it. We're going to get an arbitrary, get actually gives you an error, right? No, get's fine. Get doesn't care. No, this is this doesn't work either. I'm thinking you can get from the map. I don't know, man. I'm so, this is like, basically I want to say get from the map using one of the first values in the sequence, and if you don't get anything back, now here's the thing, it could be empty. If it's empty, who knows? Empty hash map, then getting values is irrelevant. You gotta be kidding me, man. You can't add anything to the map before you, if you don't know it's a map or not. Similarly, you can't add things to these other. Oh no. We back? Alright. I think I'll end it there. OBS